All right, let's take a look at the carbon in the world goes round and round. Carbon cycling and climate change. So it says in this lesson, we're studying the carbon cycle and the role it plays in Earth's global temperature and climate change. The carbon cycle controls the amount of carbon dioxide in the atmosphere, which directly impacts the greenhouse gas effect. It says, let's start this lesson with a game. To play the game, you'll need to be able to roll a die, either one you have around the house or Google Roll Dice, six-sided die, or click this link. So there's a link there that I've already got pulled up. In this game, you're going to be a carbon atom. You are essential. Start by rolling to see which station you'll start at the diagram at the right. If you roll a 6, keep rolling until you get a number between 1 and 5 just to start at a station. Once at your first station, roll the die again and follow the directions. Record in the table what your life as a carbon atom was like. Okay, so I'm going to go ahead and roll. Okay, it said roll again if you get a 6. All right, I got a 5. So that means that I am a hydrocarbon in rocks. Okay, so that's going to be the station that I'm at. Okay, and then once you're at your first station, roll the die again and follow the directions. Okay, so I got a 1. A river flows over the rock that you're in and dissolves the carbon substance. Go to station 3. So my form of carbon is hydrocarbon in a rock. So I'm in the geosphere. Oops, I guess there's this one, the geosphere. Okay, and now I go to station number 3, which is I'm CO2 dissolved in water. So now I'm in the hydrosphere. So now I roll again to see where I go or what happens to me. Number 4. So what does it say here? Carbon dioxide dissolved in a lake combines with minerals and deposits at the bottom of the lake. Go to station 5. Okay, so now I'm back as a hydrocarbon in rocks. Okay, so I'm in the geosphere again. I'm going to get to another sphere. Let's see what happens next. I got 4 this time. You encounter nothing to react with and you remain in the same form. Stay at this station. Okay, so I'm still a hydrocarbon in rock in the geosphere. Okay, let's see what happens next. 2. You encounter nothing. Oh, so boring. You remain a hydrocarbon in the rock. Okay, so hopefully you guys are getting the point and you go through and fill in this whole table with what happens to you. 5, the rock I'm in is subducted beneath the surface of the earth. Stay at this station. I'm going to be a hydrocarbon in rock forever. Okay, so I'm not going to keep going through this, but you will fill in all of these rows. So based on what I did so far, which of the 4 spheres did I spend the most time in? The geosphere. How does the biosphere both add and decrease the amount of carbon dioxide in the atmosphere? Be specific. Well, trees are in the biosphere and trees are in the biosphere and they decrease the amount of carbon dioxide in the atmosphere. Photosynthesis. Humans, animals are in the biosphere and they increase the amount of carbon dioxide in the atmosphere. Respiration. Cellular respiration. Which of the spheres can humans impact? So atmosphere, biosphere, hydrosphere, geosphere, all of them. Okay. It says, let's learn a little bit more about these spheres. In chemistry, when we define the parts of the Earth system, we consider where matter exists and how it moves around, using the concept of overlapping spheres. A sphere doesn't mean a literal sphere like you would study in geometry. For scientists, sphere can refer to part of an Earth system. The table lists some of the typical matter and processes found in each of these major spheres. So in the biosphere, we've got living organisms, plants, animals, including aquatic species, processes that happen in the biosphere, cellular respiration, photosynthesis, birth, death, decay. The atmosphere is the air above the surface of the Earth in layers. Processes in this sphere are wind, pollution, combustion. The hydrosphere is all solid, liquid, and gaseous water on Earth. Oceans, rivers, lakes, ice caps, glaciers, clouds, and substances dissolved in the water. Processes in this sphere: erosion, acidification, currents, upwelling, melting, snow, rain. And finally, the geosphere is rocks and soil, both at the surface and underground, including volcanic products. Processes in the geosphere are volcanic activity, earthquakes, plate tectonics, deposition, extraction of natural resources, like drilling. Oops, this got covered up a little bit. Drilling, fracking, or mining. Okay, and then there's a little Quizlet to do some practice. You go down to the match game and try to beat my time. My time was 17 seconds. Okay, after you've done that, let's talk about carbon reservoirs, sources, and sinks. So reservoirs are parts of the Earth that store large amounts of carbon, like trees, plants, soil. Underground fossil fuels are carbon reservoirs that have oil and natural gas and coal. The atmosphere is a carbon reservoir. The ocean, carbonate rocks. Carbon sources are processes that release carbon dioxide in the atmosphere, like burning fossil fuels, breathing, cellular respiration, and forest fires would all be examples of carbon sources. Carbon sinks are processes that remove carbon dioxide from the atmosphere. So carbon sinks are things like the ocean, photosynthesis, and soil. All right, let's do something. Find the illustration of the spheres below, and then to the right, there's a bunch of items that exist within this model. Start by labeling the 4 spheres of the Earth. So at the top here, we've got the, oops, that got a little crooked. We've got the atmosphere here. We've got the hydrosphere here. We've got the iosphere, I think, and the geosphere. There we go. And we're going to be adding some of these images. But first, let's do this table. Okay, well, we can add the first one. It says the item is CO2 combining with water, and it forms carbonic acid. So carbon dioxide can diffuse out of the atmosphere and combine with the water to become carbonic acid. Carbon's leaving the atmosphere and joining the hydrosphere. So this would be a carbon sink. The ocean and the atmosphere are both carbon reservoirs. Okay, so we would have CO2 coming down and adding to the H2O to form H2CO3. So it's going from the atmosphere down to the hydrosphere. Okay, for the burning tree, we could say that carbon from the biosphere chemically changes in a combustion reaction to produce carbon dioxide in the atmosphere. So this would be called a carbon source. And forests and the atmosphere are carbon reservoirs. Okay, so we've got maybe a tree here. Okay, so it's part of the biosphere and it's on fire, and so it's releasing CO2 into the atmosphere. Okay, then we've got a dying dinosaur. The dinosaur is a carbon reservoir itself, and the fossil fuel it will become is a carbon reservoir as well. Decomposers add carbon dioxide to the atmosphere. That's a carbon source as they work to break down the dead dinosaur. So this would be considered a carbon source. Animals and fossil fuels are carbon reservoirs. And then we'd probably want to draw our dinosaur going down into the geosphere. So I'm going to make him green. Here he was in the biosphere. There's his tail. He's going to go down and become a fossil fuel. Okay. Fish breathing. Fish exhale carbon dioxide. So carbon is moving from the biosphere to the hydrosphere. This is a carbon source. And then fish are carbon reservoirs, and so is the ocean. So for our picture here, we want to draw the fish maybe on the edge between the biosphere and the hydrosphere. So we've got our fish. Moving carbon in that direction. Okay, then we've got our tiger breathing. Tigers exhale carbon dioxide. Carbon is moving from the biosphere to the atmosphere. So this is a carbon source. The tiger and atmosphere are carbon reservoirs. So we would want to draw this guy. See if I can find an orange. There we go. We would want to draw him here. There's the little tiger. And he's breathing out. And so he's moving CO2 from the biosphere into the atmosphere. Okay. Next, we've got truck delivering your Amazon order. Combustion occurring in the truck's engine converts carbon from the geosphere, fossil fuel, to carbon in the atmosphere, carbon dioxide from the exhaust. So this is a carbon source, and fossil fuels are carbon reservoirs. So we'll kind of draw our truck down here. Okay, and it's coming from the geosphere, the fuel, and going into the atmosphere. And last but not least, we've got algae. Algae are moving carbon dioxide from the hydrosphere to themselves, the biosphere. The ocean and plants are both carbon reservoirs. So I would want to draw these algae maybe on the border. And so CO2 from the hydrosphere is going to become a part of that algae. And you can also come up with your own example there as well. Okay, so a couple of last check-in questions here. It says, when we say something is a carbon source or a carbon sink, what are we talking about? We're talking about carbon dioxide. Is it also true for carbon reservoirs, or can carbon be found in other compounds or forms in carbon reservoirs? Be specific. Carbon can be found in hydrocarbons, carbonates. Okay, so in a reservoir, it's not always carbon dioxide. Consider the global carbon cycle from the 1990s shown above. Can something like the oceans be both a carbon sink and a reservoir? Yes, absolutely. I'm going to put a Y here. At least one example of something that can be both a carbon sink and a reservoir. Trees can be both a carbon sink, photosynthesis, and a reservoir. Trees are made of mostly carbon atoms. Can something be both a carbon source and a carbon reservoir? Yes. Trees can be a source when on fire and a reservoir as mentioned above. Can something be both a sink and a source? Yes. Trees can perform photosynthesis and be a carbon sink and can be set on fire and be a carbon source. And then last, there's this animation showing the entire year of 2006 and kind of where the carbon dioxide is. So watch this video first, and then I'll help you out with these questions. Explain the seasonal changes in CO2 in the northern hemisphere. Well, in the spring and summer, the plants and trees performing photosynthesis sink carbon dioxide from the atmosphere into the biosphere. And then you'll see this like pulsing in the video over portions of South America, Africa, and Southeast Asia. And that's because during the day, plants absorb CO2 as part of photosynthesis. And you might remember this from biology class. At nighttime, they exhale it. Since there is no sun, they are respirators as they work to burn their sugars for energy. Oops, this should be nighttime. And anything else you thought was interesting? I just thought it was sad that the countries producing the least amount of CO2 are the ones most negatively impacted by the consequences. So anything that you noticed from the video is fine for that. So, all right, there you go.